Okay, honors physics students. I gotta keep track of where I'm at. Today's Monday, you're gonna watch this on Tuesday. So, let's make sure everybody's cool with this lab. So you got this lapse time, obviously that's gonna be 1.10. This is gonna be 2.40, 4.45, 6.80. And then we went through that yesterday. This is going to be 2.30. This is going to be 2.50. So you got to figure out when it's going to hit and when it's going to bounce back. So sorry about that. So here's the whole deal. So your position time graph is going to look something like this. So that's going to be 3 meters, and that's going to be out here at 6.80 seconds. Now, the hard part is your velocity time graph. Okay? That's going to look something like this. So you're going to start up here, probably something around 1.4 meters per second. Okay? And this is going to be 2.40 seconds. So this is when you hit. Here's when the spring is compressing. Here's when the spring is expanding. And this is when you leave the wall. So it's rolling along, right? It's going to hit the wall, boom. You're going to have a big negative acceleration. You're going to have the same negative acceleration here. But then you're going to have negative acceleration with negative velocity. That's going to make it speed up. And then after it leaves the wall, then your acceleration becomes positive. Now you're going to start to slow down. You guys, now you've got positive acceleration with negative velocity, and that's going to make you slow down. So one of the things you want to calculate is that area. Well, treat this thing like a rectangle, okay? Come up here and take this kind of average velocity, which is probably going to be about 1.2 meters per second, something like that. Multiply that by that base, which is going to be 2.4. Look what happens with the units. You're going to take meters per second times seconds. The seconds are going to cancel out. You get meters. That's displacement. This is going to be your area. Down here, you're going to have a negative velocity multiplied by this amount of time. Okay, now look at this. Here you're going slower, but so that's why it takes you longer to get back. So this area here is should be, theoretically, this area here should be negative 3 meters. This area here should be positive 3 meters because you end up back at the reference point, everything adds up to 0. Now, if you look at this in terms of F equals ma. So when that cart was rolling towards the wall, okay, here was the plunger, right? So it had some positive velocity, right? Now, there wasn't much friction, okay? So as that thing was rolling along, your velocity vectors to a certain extent just stayed the same length. They were getting a little bit smaller, okay, but not a whole lot. Now, remember, if your velocity and your acceleration vectors are in opposite signs, that means you're slowing down. So I had some amount of positive velocity going in this direction. That means my acceleration vectors had to be pointing in the opposite direction. Now, there wasn't much acceleration because there wasn't much force. So if you look at F equals ma, when it was rolling along, I had some negative force acting in the opposite direction of motion, which is what we're going to call friction. Oh, okay. I'm going to have some negative acceleration. Now look at this. Mass is always a positive value because it's a scalar quantity. I can't have negative mass. So what that means is that whatever sign my acceleration is has to be the same sign as my force. So when I'm rolling, I had a small negative acceleration creating a small negative force. That's why on my velocity time graph, initially I had a pretty shallow slope. Now, all of a sudden, bam, it hits the wall, okay? That plunger begins to get compressed. Now I have a much bigger negative force multiplied by mass, which is going to create a much bigger negative acceleration. Now this line starts to drop like this. Now, the slope changed, but I didn't change direction because the slope didn't cross through 0 meters per second. So slow it down, bam, I hit the wall. Okay, it starts to slow down. Now at this point, this spring is fully compressed. Mother Nature doesn't like that. Mother Nature likes kinetic energy. So at this point, this spring begins to expand, right? But now, that spring is pushing, right, you back with a negative acceleration, which is now making you speed up, because now that spring is pushing. So now it's going to leave the wall. Now, here's what you visualize. Now this cart is rolling in the opposite direction. Now, as it rolls, now it has negative velocity, but now it has positive acceleration because now it's going in the opposite direction of motion. So when it was rolling in, I always had negative forces. After it leaves, now I have a positive force because it's going in the opposite direction of motion. So remember, and this will play out large later on, force always acts, frictional force always acts in the opposite direction of motion. So if the cart's going this way, friction acts this way. If the cart's going that way, friction acts in that direction. Okay, so hopefully that kind of answers all your questions. Make sure that you show your work on these questions, okay? I want to see something times something, okay? On both of those. Anyway, that should answer all your questions. Make sure, I beg of you, okay? Listen to me, I beg of you. Please go through on the bottom of this page 1 and you do everything that has to be done for this, okay? These 4 points: hits, compressing, expanding, slowing down, speeding up using arrows, label the sign of velocity and acceleration. Okay, so this is you're going to see this tomorrow, your tomorrow, my tomorrow, which is going to be Tuesday morning. You're also going to have a video link that explains the graphical addition of vectors. So you're going to have all of that to watch. And don't forget, this lab is due on Tuesday. I got to keep my days straight. Anyway, so look for videos.